Alright, so this is gonna be a conservation of momentum walkthrough 3J. So a 7 kilogram card, so M, and just for simplicity I'm gonna call it MA, 7 kg, so it's card A, so MB is 3 kg. Initially held together at rest, so they're both starting from rest, so VAI is 0, VBI is 0, and you can just substitute A and B as 1 and 2. It doesn't really matter, because as long as you know what you're substituting for. Cards are pushed apart, so when the spring is released, the cards are pushed apart. After the spring is released, speed of the card B is 6 meters per second, so VBF is 6 ms. And what is the speed of card A after the spring is released? Well, then we know momentum before is equal to momentum after. Alright, and we know that PAI plus PBI, so the initial momentum of A plus the initial momentum B, well, it's equal to the final momentum of A and the final momentum of B. Alright, and so the momentum, we know momentum, the formula for momentum is P is equal to MB. So right now we're just going to be substituting everything. Well, MA VAI plus MB, oh man, I almost forgot there, VBI is equal to MA VAF, oh, okay, MB VBF. Alright, so mass is 7, and that's going to be 0 plus 3, also 0, MA, 7. We don't know what the final velocity of A is because that's what we want to solve for. And mass of B is 3 times 6 because the final velocity of B is a 6. So all you do is replacing the variables here. That's all you're doing. So Z, 0, VAF plus 18 minus 18 minus 18, 7, VAF, 7, 7. So you're going to get 2.5, somewhere around 2.5. And so you're going to get negative 2.6 meters per second is equal to VAF. And so the answer would be D, because they just want the magnitude. We want the speed. They want the velocity. The negative would be the velocity. But the speed is a scalar. The speed is a scalar. Okay? Speed is a scalar. So you're going to take the magnitude. 2. A blue lap car is traveling west on the track when it collides with and sticks to a red lap car. So they're sticking together. Right? They're both traveling west. 2 cars collide, and then they both stick together. So we're going to write magnitude of momentum of the blue car before collision. So the momentum before, and we're going to call the blue car 1. Alright, so let me give you a key. So P, so 1 is the blue cards, okay, and the red card is gonna be 2, so that's object 2. So the initial momentum of object 1 is 2 kg meters per second. And the magnitude of the momentum of the red card, and that's going to be object 2, and so is 3 kg m times s. And so the magnitude of the total momentum of the 2 cards after collision is what? Well, this one is a fairly simple problem. Well, your momentum before is going to equal to your momentum after. And so, well, P1i plus P2i is equal to, well, since they stick together, they have the same mass and the same velocity. Well, then they're gonna have the same momentum. They're sticking together, so it's the same. They have the same momentum. It's treated as one object now. When two things collide, they're one object now. They're one object, and so I'm gonna call this P total. And so 2 plus 3 is equal to 5. Sim maths. D. So the answer is D. Diagram shows an 8 kg card, so we'll call that mass 1 is 8 kg. Mass 2, oh well, it's giving us velocity, so let's do that. So velocity, initial velocity of 1 is 4 meters per second. Mass 2, and so the mass 2 is 4 kg, and then it's moving left. So you want to take care of your sign. So it's negative 6 meters per second now. Negative 6. So you always want to take care of your signs. After collision, the 4 kilogram cart moves to the right at 3 meters per second. And so the final velocity of cart 1 is 3 meters per second. Perfect. What's the velocity of the 8 kilogram cart after collision? Oh, it's telling us actually that the 4 kilogram cart is moving to the right. And so V2F is 3 meters per second now. So be careful of your signs. Be careful of your signs here. Because initially cart 2 was moving to the left at negative 6 meters per second. But at V2, after collision, it was now moving to the right. So it's moving to the right at 3 meters per second. So be careful of your signs. So what's the velocity of the 8 kilogram sign? So they want to know what your final velocity of object 1 is, right? They want to know what that is. So set up your equation. P before is equal to P after. Alright. So P1i plus P2i is equal to P1f plus P2f. And so now we're going to replace momentum with mv. So m1 v1i plus m2 v2i is equal to m1 v1f plus m2 v2f. So mass 1 is 8, v1 is 4, plus 4, negative 6, m1 is 8, plus 4, v2f, 3. So again, all I did was place all my notes into this formula. So 32 minus 24 is equal to 8 v1 f plus 12. 8 1f plus 12, so minus 12. So negative 4 is equal to 8 v1 f divided by 8 divided by 8 is negative plus 4. No. It is negative 0.5 meters per second. So it's negative 0.5 meters per second. You know it's going to the left, so the answer is A. So a 1 kilogram part. So we're going to call it mass 1 kg. With the speed of so the initial speed is 0.5 meters per second. Collides with a second. So they're both having a mass of 1 kg. Initially at rest. So m2, the initial velocity of object 2 is 0. and the carts lock together, so they stick together after collision. If they stick together after the collision, they have the total mass and they have the same final velocity. So they have the same final velocity, and that's what we want to figure out. So P before, P after, P1i plus P2i is equal to the total momentum after collision, because again, the cart sticks together, right? They stick together, meaning that they're only one mass. Okay? So your initial momentum 1 is m1 v1i plus m2 v2i is equal to total momentum. So m total v final, right? So 1 v1i 0.5 plus m2, which is also 1, mass to velocity 0. Your total mass is 2. We want to find out what our final velocity is. So 0.5 is equal to 2 vf. And so that is your speed, 0.25 meters per second. So the answer is 4. Five. A 3.1 kilogram gun. So mass of 1 is 3.1 kg. And that's again, 1 is the gun, and 2 is going to be our bullet. Alright, just to make it easy for you. So initially free to move. So V1 initial is 0. So M2, the mass of the bullet, is 0.15 kg. So the initial velocity of the bullet as well is also 0. And then the final velocity says the bullet leaves the gun with a speed of 500 meters per second. So the velocity of the bullet, V2 final, is 500 meters per second. Well, what is the speed of the gun, right? We want to know what the speed of object 1 is now. So we're going to set up our formula, P before, P after. I'm going to assume by now I don't need to write everything because you've seen it written multiple times. So I'm going to give myself a little bit of a reprieve. That's how you do it, I guess. And then they move apart. So M1, V1F. Running out of room. My worst nightmare. Well, that's V2F. Just so you guys know. Just so you guys know, that's V2F. Alright. I have to make concessions here. So M2. That's 0. M1, 3.1. V1F is unknown. Plus, hold on. I'm just gonna make this easier for myself. So if you know your initial velocity of both the bullet and the gun are 0, the initial velocity of the bullet is 0 because it's initially in the chamber. It hasn't been fired yet. The gun also isn't moving. So the initial velocity of both of the masses, is 0. Yeah, both of the masses' initial velocity is 0. So anything times 0 is going to be 0. So you just put that as 0. So M1, 3.1, V1F plus M2, V, and then V2F V2F is 500. Oh man, that looks terrible. No room. Sounds like my note sheets. No room there either. So 0.0115 times 500 is going to be 7.5. Okay, 7.5 So minus 7.5 minus 7.5. So negative 7.5, 3.1 V1F divided by 3.1 divided by 3.1, and you get 2.4. 2.4 meters per second. Alright, and that's the answer. I need to remind myself to give myself more room. A 1 kilogram cart, so mass 1 is 1 kg. Is moving with initial velocity, so initial velocity of 1.5 meters per second. These clouds and sticks within the summer cart initially at rest. So the mass of 2 is unknown, so we don't know what. I think when it says similar cart, oh, that's not even a math question. Alright, well, I'll still write my notes out. The initial velocity of 2 is 0. So after the collision, 2 carts move off together with a velocity of 0.25 meters per second due east. So the velocity of after they collide and stick together is 0.25. The total momentum of this frictionless system is what? This is conservation of momentum. The momentum before is the same as your momentum afterwards. So it's conserved, so it's the same before and after the collision. So it's 0. It's 0. That's the answer. It's conservation of momentum. Please tell me you guys remember that. Please. Please. Mass 1, 0.500 kg. Traveling to the right, so the velocity of object 1 initially is 2.2 meters per second. A 100 kilogram car moving to the left. So mass 2 is 0.800 kg. So this time the car is moving to the left. Alright, so it's moving to the left at negative. So the speed is going to be the velocity is going to be negative 1.1 meters per second because it's going to the left. What is the magnitude of the total momentum of the two-cart system after collision? So they want to know what your total momentum after collision was. They want to know what after is, right? What your total momentum of the two-cart system after the collision. Well, we know what that P before is equal to P after. So to figure out what P after is, we just need to know what P before is. So what's the P before? Well, it's P1I plus P2I. And we further simplify that, M1 V1I plus M2 V2I. And now I have 0.5, 1.1, no. I'm sorry, there's an error there. And so the initial velocity of 2. So V1I is 2.2 plus 0.8 negative 1.1. So 2.2 is 1.1 plus 0.8 times 1.1, negative 88. Negative 8.88 is equal to P after. So 1.1 minus 0.88 is 0.22. And so that's your total momentum, 0.22 kg m or s. And so the answer is A. I hope that was helpful.